Good morning, ladies and gentlemen. Very warm welcome to all of you. Today, 10th of June, 2023. So we are starting our first series on lightning protection. So before we begin, I would like to inform you all that this webinar is presented by NFE, National Federation of Engineers for Electrical Safety. I know most of you who are participating in this webinar are members of NFE. I will just like to show you a website of NFE. So this NFE is nothing but National Federation of Engineers for Electrical Safety. So our vision and missions are given very clear a statement. We shall strive to achieve our vision through getting accredited of products and personal certification. We shall focus on electrical safety by design, manufacturing, installation, and maintenance of electrical product, and installation by competent and qualified manpower using quality resources, including product, processes, and procedures. And if you look at what we do here in NFE, create awareness on electrical safety. So we beginned since last 2 months. We are now almost 5 months old association. Within this 5 months, we are over 450 members, and we have done fantastic events. We just concluded 2 days back in Ahmedabad. If you look at here, though it says upcoming event, this is just concluded in Ahmedabad. So we associated with the Bureau of Indian Standard. We went around the country talking about National Electrical Code of India 2023, which is now made mandatory. It's mandatory to be designed, install, and maintain. So we did complete in Ahmedabad. Then we were in Hyderabad. Before that, we were in Mumbai, then Bangalore, then Chennai. We begin NFE programs with one major seminar on decoding National Electrical Code of India in New Delhi. So in 5 months, we have tested over 1,400 physical seminar. Mr. Apavo sir, who is our General Secretary, along with Krish, we went around the country. We covered as much as possible. It was 2-day hectic seminar. And Mr. Gopakumar, the president and our general secretary, is compiling a document, the summary of this webinar that we conducted, the seminar that we conducted. So will be released very soon to all the members of NFE. Why you should become a member of NFE? If you look at here, it's very simple. If you're not a member, just go here, open the website called nfees.org. When you click here, you have an option to become a member. So once you click here, you have either you can become individual member. If you are an international member, very simple. And if you're a student, it's only 500 rupees a fee. Then we have corporate. So we have very good response from a lot of corporates. Corporate advantages, 4 members can participate in all our program. Some of the programs are free for members, only for member. Some of the accreditation or a certification program that we are now going to launch very soon, which will be on chargeable basis for non-members. A member will get subsidized rate. So these are the benefit. If you go to the website, you will get to know. The membership is online. The moment you become, when you make your payment, you'll get your certificate, welcome address, payment receipt, everything on your mail. So I would urge my friends who are joined in this webinar to join our hands to make our nation electrically safe. So only by coming together, we can achieve our goal, which is making our nation electrically safe. So with me, ladies and gentlemen, I have the speaker for the day, Mr. Gopakumar, who is also the president of NFE and is the managing director of Cape Electric. As you all know, the well-known face has been addressing since last 2.5 years over 200 webinars on various subjects. He's been member of technical committee of NEC IS 732, ETD 30, ETD 50, National Building Code, and international organization like IEC. So he has been traveling around, making sure that the codes are reaching to every engineers in the country. Everybody understand about the code. Myself, my name is Dominic. So I've been in the fire industry for quite some time. So the reason to take active role in NFE is to understand the root cause for the fire. Whenever there's a fire, without even investigating, we just say it is due to short circuit. So I thought, why this is happening? Why is it? Is it just because wrong installation we are getting fire? Or is it some other reason? So I'm working very closely with NFE to ensure that we educate every engineer, every installation engineer, that how to do best practices, how to install and maintain electrical systems. So ladies and gentlemen, today we are talking about lightning protection measures for outdoors. So our speaker, Mr. Gopakumar, will be presenting and sharing valuable insight on safeguarding living being in open areas and outside structure from the hazards of lightning. So in this first edition of lightning protection, we will focus on shedding light on the accident that can occur due to sight flash, touch potentials, and step potentials, and provide a clearer understanding of risk associated with lightning strikes by exploring the principle outlined in the IEC TR 62713 standard, which address safety procedure for reducing risk outside a structure. So we will dwell into effective lightning protection measures today. Furthermore, this webinar aims to dispel any misconception and misunderstanding surrounding lightning and its associated hazards. By addressing common myth and clarifying important concepts, we can empower ourselves with accurate knowledge and make informed decisions when it comes to lightning protection. I encourage all participants, regardless of your background or level of expertise, to actively engage in this webinar, put your questions, listen to the speaker, and make some notes. Whether you are a professional in the field of electrical engineering, a safety officer, or a fire officer responsible for outdoor environment, this session will provide valuable insight that can be applied in various scenarios. So, together, let's delve into the world of lightning protection measures for outdoors as we strive to create safer environment and protect lives from the unpredictable forces of nature. So thank you. Let's begin our exploration of lightning protection measure. I now welcome our speaker, Mr. Gopakumar.
Thank
Sir,
you, Mr.
over to you,
Dominic.
sir.
Thank you,
Thank you,
Mr. Dominic. Thanks for the introduction. So, as usual, I think we have about 200 plus participants, or maybe 300 are going to participate today. So, I'm sharing my screen. I hope my screen is visible to you.
Yes, sir.
You are seeing the presentation in full screen or in half screen?
It's full screen, full screen.
Full screen. Are you sure? Because I have
Yeah, Lakshmi,
The,
you
the
have
full screen is visible, right?
Yes, sir.
Lakshmi is, yeah.
Okay. Right. So, yeah, because I'm using two screens. Sometimes these two screens will create confusion.
No.
Sometimes people
Even
will be looking.
participants saying it's full screen. So be confident we are in full screen, sir.
Yeah. So
Someone says
thank you very
black
much.
screen visible. No problem.
Yeah, thank you very much, Mr. Dominic. Thank you.
Okay, thank you.
So today we are going to discuss about one of the important subjects of lightning protection. Very important subject, especially the monsoon is starting, and all of you know that during these 3, 4, 5 months, last few years, we are listening to accidents, death of farmers, people, those who are working in farms or outside building, they are getting killed, and sometimes a lot, tens per day. And probably the annual sum of the report says more than thousands are getting killed every year due to lightning across India. So the idea of the webinar is to explain you what exactly you should do, or a little bit from the standard, the Indian standard. The Bureau of Indian Standard had published the standards IEC 62, IS IEC 62305, part 1 to 4, which is talking about protection against lightning. Then 62561 is not an IS standard, but it's an IEC standard, which is about the components of lightning protection system, which is not yet an IS standard. But the next three, IEC 62713, 62793, and 62858, these three are becoming an Indian standard, out of which today's our discussion is about or little bit connected to IEC 62713, which is safety procedure for risk reduction outside the structure. Now, before going into the subject, please understand that the subject 62305 part 1 to 4, which we generally use for lightning protection of structures, means a building, a proper building. 62305 has to be, the principles of 62305 has to be applied to a proper building. Don't try to apply the same principles for in a farm, in a open area. This is, first of all, those principles are not applicable. The 62305 is applicable for a proper structure, because lightning is not only a current flow, which we generally think. The current or the energy consists of, there is a heavy specific energy, charges, and the effect of lightning is not only a current flow. It can heat material, it can produce large flashovers, temperature rise, not only at the point of strike of the lightning. If you have a loose contact, almost 30,000 degrees of temperature may be produced in a loose joint. So lightning is not like the other parts of other subjects of electrical engineering. So lightning protection needs a very special and very specific subject. So let us look at what exactly is IEC or IS IEC 62713, which is yet to be published. Probably in a week or two this will be published, is talking about. So during lightning, the most important subject is don't try to be the tallest object in the area. If you are the tallest object in the area, the lightning probably is hitting the person, and you know the effect. The current flows through the person will create big problems. Probably the person get killed. So don't try to be the tallest part in the of the installation, or tallest part in the location. The second effect is side flash. If you are standing near to any objects, maybe it is near to a building which is having a down conductor, or maybe near to a tall tree, or tall or small is immaterial. If you are standing near to a tree, the chances are, as you can see in the picture, side flash. Lightning may be hitting the tree, and from the tree branches, maybe the current jumps into the body of the person. As a result, the person will be hurt. So, direct strike and side flash. Side flash means lightning is hitting something, and from the place where the lightning current is flowing, there is a chance that current may jump into the body of the person. For example, instead of a tree, you imagine a wooden pole. So the wooden pole, there are some propagandas going on in India. You use a cycle tire and a wooden pole. So if you have a 8 mm conductor connecting the cycle tire to the earth electrode, and if the joints are not proper, the side flash will happen. And if there is any bend in this 8 mm wire, or if there is a bend in the down conductor, side flash may happen. So lightning is not like what you think. It is a high frequency, high energy current flow. It is not like a DC current which is flowing through a conductor. We have to treat it definitely different. The third dangerous part is don't stand under unearthed metallic roof. You can find these wordings in the standard: structures with metallic roof and non-metallic supports. What does this mean is, if the support, let us say the supporting is also a metal pipe, then you are safe. But if the supports are non-metallic, then the situation is dangerous. The lightning may hit the sheet, and probably from the sheet, from the metal sheet, the discharge may be happening to the person. So this is dangerous. Also, touch voltage. Imagine partial lightning current is flowing through some, not the full lightning, partial lightning current is flowing through some metallic objects. Even in a good building, in a building with protective equipotential bonding, probably lightning current may be flowing through some of the metallic parts. And if you are standing outside the building and touching one of these metallic parts, there is a chance of touch voltage. If you are standing inside a building, and if you are in a reinforced, in a building with reinforcement, steel reinforcement, then this chance is nullified. Whereas if you are standing outside in any kind of building and touching the metallic part, then this problem it exists. So the touch voltage exists outside the building. So I repeat, if you are standing inside a building which is having steel reinforcement and the protective equipotential bonding as per IS 732 or National Electrical Code is made, then inside the building this problem doesn't exist, but outside the building touch voltage exists. So it is due to, you can see the metallic structure arcing resulting from induced voltages and touch voltages. So the feet is at one voltage and the place where you are touching is at a different potential. People get injured in this case. The biggest problem is step potential. Step potential means whenever there is a current flow through the soil, through earth, please note that lightning current flow is, people, even scientists say it's a surface phenomena. The current flow, most probably it is going through the surface, not deep into the earth. So step voltages, as you can see in the picture, between the steps of a person, a potential is due to the potential gradient. There is a potential difference between the steps, and current may try to flow through the body, which may injure the person. So step voltages are highly dangerous. Now the standard has recommended how to get rid of this step voltage. For example, if you are near to a tree, you have to be at least 10 meters away from the tree. So that means in a tree, up to 10 meters from the tree, the step voltages can injure person. In a very good lightning protected structure, probably it is 3 meters. From the structure outside, 3 meters is a danger zone. I have the pictures, I will show you. So step voltage is the reason for death in most of the cases in case of lightning strike or during lightning strike. Please also note that step voltage is also applicable for extra high voltage transmission or distribution substations, extra high voltage. So here you can see a typical picture of step voltage. Voltage gradient means the point of strike or point at which the current is entering the soil will have a very high potential with respect to a faraway place, and a person standing across this potential gradient will experience step voltage, and the current will try to flow through the body, which will injure the person. So two examples are here. The lightning is striking the tree, and probably the person standing nearby is getting the touch or the step voltage. So in the lightning protection standards, we say it's an indirect impact. Similarly, touch voltage. Touch voltage is nothing but a person touching some metallic objects where full or partial lightning current is flowing, and his feet is at a different potential. As a result, the person may get injured. So the problems are direct strike on the body of the person, side flash of different kind. For example, side flash from a tree, side flash from a building, side flash from an unearthed metallic object. Then the problem is step voltage. Then the problem is touch voltage. So all these problems, whenever there is an accident, we can analyze the reason why such kind of accidents are happening. With respect to step voltage, there are incidents which says thousands of gods or 300 plus gods or animals got killed in one incident. So such large animals, we must think that they are not standing in a small area, they are standing on a large area. Step voltage is even applicable for a large area. Probably in the standards, it is restricted to something about 10 meters. Anyhow, I have the picture, I will show you. The effect, possible injuries. The voltage can climb up to 300 kV between feet to head of the person. A person who is standing from the head to the foot, up to 300 kV will be created once when the lightning current is flowing, not through the body of the person, but somewhere else nearby. And all these effects are illustrated and explained in the standard. Most often the current flows through the surface, through the body, not internal through the body, but of course there will be the effect also internal. The skin may get burned, and all these explanations are there in the standard. Probably once when the standard is published, you can go through the standard and you can understand. A part of this presentation, the PPT of the presentation will be shared to you so that you can read the effect and try to understand the kind of problems. The kind of injuries are also explained in the standard. One of the problem which you must understand is you can see the picture of a lady sitting. She was wearing some metallic ornaments such as a necklace or some metal, the gold jewelry. So during lightning, what has happened is the jewelry is exposed to a very high temperature because of some effect, which is also explained in the standard. As a result, the person get burning on the skin. It's not a deep burning, but it's surface burning. You can see the picture. The dress of the lady is a little bit dark. This is due to the ornaments or due to some metallic things which she was holding during the time of lightning. You can also find these pictures from various parts of the world. The current flow, which is burning the skin. Technically, these people are not struck by the lightning. They are not touching anything. They are not on the step voltage. They have some metal objects on their body, like ornaments on the body. And these metal objects are creating a high temperature, which is burning the skin. So this is also a problem which we need to analyze and address properly. So if you are hurt badly, then the object, you can be mildly injured or moderately injured or severely injured. The methods of safety measures and what you should do, how you should make the CPR are explained in the standard. The effect of mildly injured, moderately injured, and severely injured is also included in the standard. Most probably the standard will be coming within 10-15 days. So you can download the standard, you can buy the standard and go through it. So it will be very difficult to read through each and every part of the explanation. So CPR may be required sometime. It may not be, because if it is a severely injured case, then CPR may not be possible because before that the person is dead. How to react during lightning? This explanations in the standard explains you detect a lightning strike. Lightning detection on early warning systems are always available, or it is already available in India. There are several agencies, those who are giving this information. I think ISRO it is there. The IMD is having some app or something like that. So you can register through these websites so that you get a warning. Generally, you need to have a warning at least 30 minutes in advance, because this 30 minutes is required for you to move to a safe shelter. So if you are open outdoors, then you are in trouble. The second method which we say is watching the approaching cloud and listen to the sound. Then if the sound is, the distance, the time between the sound and you see the lightning and the sound divided by 3, you get the distance of the lightning strike. That means you saw the light of the lightning at 0, then you start counting. Let us say at 15, once when you count, you hear the sound. So that means the lightning strike is 15 divided by 3, about 5 kilometers away. So what is recommended in the standard is from 5 kilometer, and outdoor sports event should be interrupted if the lightning strike is close by, nearby, maybe closer to 5 kilometer. Then all the outdoor activities must be stopped, and you should not go near to isolated trees, because the lightning is going to strike in your area on the next moment. Then there is the 30-30 rule, which can be applied if you are outdoor. I don't want to explain it. We have it is there on the standard, and we have it in a book as well. Once when the lightning strike is over, after listening to the last thunderstorm sound, you have to wait at least for 30 minutes, and then only you are. It is recommended to go out, because most of the lightning casualties occur after the storm has passed or dissipated. That means after 5 minutes, if you go out, probably there is a strike which may be endangering the persons. So be careful. Lightning is not like the normal electric shock, where we can see from where the electric shock you are getting, and if you try to not to touch that particular area, sometime you are safe. Lightning is not like that. So the unsafe areas you can see in the picture. During 2007, we published a handbook on lightning, what to do and what not to do. I took these pictures from that particular book. I mean 2007, it's almost now 15 years back. The first book was published. So you must avoid all outdoor activities, and you have to be inside a safe shelter. Safe shelter we will explain later. Also touching in an unprotected building, if you are touching some metallic objects, of course you will be in trouble. And if you are wearing something, of course again you are in trouble. Safe shelters, yes, the cars or train or metallic sitting inside metallic objects such as car, bus are safe. Inside a building is safe. These we say as lightning protected or safe places for lightning. Inside a building, of course, if the building is unprotected, then you are not supposed to use electricity, preferably. Then you are not supposed to use any of the activities which is shown in the picture. But nowadays, with the advancement in the technology, you can improve the equipotential bonding in such a way that if all the safety measures, electrical and electromagnetic safety measures are made in the building, actually you can use these activities. But still, as a safety measure, don't touch the metallic objects. This is as a precaution, we say, but the buildings can be made safe. If you are near to taller structures, especially light pole, you are outside and you are near to a light pole, the standard is recommending, you can see here a 20-meter light pole. 20 meter is a very high mast lighting. 1 meter you should not keep closer to 1 meter. You have to be 1 meter away from the structure. The standard recommends 1 meter. Better, it says better 3 meter, 1 meter or better 3 meter. So keep 3 meters away from any of these light poles and other objects. So practically, if you are 3 meters away, now in the picture you can see 1 meter away, but imagine 3 meters away. So at some area you are protected from a direct lightning strike, because strike will go to the metal pole rather than hitting the person. But most important is you keep this distance 3 meters, and don't use umbrellas or hold any long metallic or other conducting objects in your hand, because if you hold an umbrella or if you hold some metallic objects, there is a chance of current jumping from the the street light pole to that particular metallic object exist. As a result, you will be get hurt. If you are near to a tree, you can find this picture in the standard. You have to keep at least 10 meters away from the root of the tree, the bottom of the tree, and from the branches, minimum 10 meters, because the lightning may be jumping up to 10 meters. At the bottom, the step voltage may be hurting you if you are closer to the tree. So minimum 10 meters away from the tree must be kept. In one of the standard, the American standard, NFPA 780, Annexure F is explaining about protecting the trees. This is not from the Indian standard, this is from the American standard. NFPA, sorry, NF is missing. It is NFPA 780. Annexure F explains protecting a tree. Please note that these recommendations in the standard is not to protect people, it is to protect a tree, because lightning may be hitting the tree and it may be damaging the tree. What is written? Trees with trunks within 3 meters, 10 feet of a structure, or with branches that extend to a height above the structure should be equipped with a lightning protection system, because of danger of side flash, fire, or superheating of the moisture in the tree, which could result in the splintering of the tree. So this is to protect the tree. It also, the second para of the standard says, adding protection to the tree is not for safety of people seeking shelter under the tree during thunderstorm. Possible side flashes, step potential, and touch potential could threaten the safety of people seeking shelter under the tree, even if the trees are protected. So please don't try to apply this principle to protect the people. You can protect a tree by making a conductor through the tree. Of course, every year you have to, once when the tree grows, you have to modify the connections, modify it accordingly. So this is a recommended method in NFPA 780 for protecting the tree. If you have tall trees near to your house, probably this is a good measure, but not to protect people. And please note that it is not included in the IEC standard or in the Indian standard. If you are outside a building, a well-protected building, if you are outside a well-protected building, there are two problems. One is the step potential and next one is the touch potential. In order to avoid touch potential in the sense the down conductor is going through the building, and if you are touching the down conductor or any earthed metallic object connected to the down conductor, probably you are getting a shock. In order to avoid that and to avoid the side flash, you are supposed to be minimum 3 meters away from the down conductor. You can see in these wordings in the ISIC 62305 part 1. Part 3, of course, in certain conditions, the vicinity of down conductors of an LPS may be hazardous to life, even if the LPS has been designed and constructed according to the above mentioned requirement. The hazard is produced to a tolerable level if one of the following condition is fulfilled. Under normal operation condition, there are no persons within 3 meters from the down conductor. So your building is well protected, but from the down conductor, chance of an accident to a person exists, a person who is outside the building. So you must keep 3 meters away from the down conductor. A system of at least 10 down conductors is employed. If the down conductor is more than 10, this chance of the flashover is quite less. That means if you have 1 or 2 down conductor, the chance of this side flash is much more. Then the contact resistance is also explained, 100 kilo ohm, the contact resistance between the person and the soil. That means it is really an insulated floor. If the floor is insulated, then the chance is a little bit less. Similarly, the step voltages are also mentioned in the standard in order to avoid touch voltage. And in order to avoid touch voltage, what you should do is the down conductor where I am moving the cursor, the down conductor of that part of the building up to, let us say, for example, 2 meters, 3 meters down conductor where a person may be touching must be insulated. Insulation of exposed down conductors is provided giving a 100 kV, 1.2 to 50 microseconds impulse withstand voltage. Example, at least 3 millimeter cross-linked polyethylene. So if you are using a 3 millimeter XLP cable at the last 3 meters, which is tested for a 100 kV impulse voltage, then the problem of touch voltage can be reduced. Then the second recommendation is a physical restriction or warning notice. So you put a barrier so that nobody goes near to the down conductor, which is unfortunately very difficult. Or you put a warning notice that people are not going near to the down conductor during this time. But the question is whether people will read it and really understand and do it properly is a question. Regarding step voltage, equipotentialization by means of a meshed earth termination system will be helping. Physical restrictions. Physical restriction is either you make a equipotential meshed earth termination system. I have a picture I will show you in the next. Or restrict so that people are not going near to the down conductor at least 3 meters. They have to keep 3 meters away from the down conductor or from the earthing. So basically, even in a well-protected building, you must keep at least 3 meters away from the down conductor, away from the earth termination system in order to be safe. Now, how to make the meshed earth termination system? This picture you can find in the National Building Code of India. So here the dotted line shows a ring conductor, let's say, for example, which is 1 meter away from the building and half meter below soil. All around the building as a type B ring earthing. Then the ring is further extended. After 3 meters, there is one more ring, again 3 meters, one more ring, again 3 meters, one more ring. And each of these rings are again half meter below. The first one is 0.5 meter, next one is 1 meter, next one is 1.5 meter, like that. This is a kind of a voltage grading. So by extending these rings, step voltages can be controlled. So people outside the building are safe in this particular case. Else, you can also make an RCC flooring outside the building, and the RCC flooring and the down conductor can be connected together. As a result, you can make an equipotential bonding also. So to protect people outside the building, this is required. Don't think that you have an air terminal, you have a down conductor, and you have one earth electrode, and then the rest is safe. No, it is not like that. You have to keep the distances, or you have to put the appropriate measures in order to protect people, those who are outside the building. Now I am going to show the photographs of one of the lightning protection system installed very recently, which was propagated, which was written or spoken by the media or by the newspaper agencies in the eastern part of India. This is a school in Orissa. You can find out a early streamer emission, which we say a non-standard lightning protection air termination system installed in the school with a down conductor. Now the down conductor, there are two rods at the top of, there is an ESE rod as well as there is a normal Franklin rod. Then both are connected to through two down conductors. You see, very important subject of lightning protection is down conductors must be all around the building. If you are routing all the down conductors through one side of the building, that itself is a violation of the standard. And depending upon the size of the building, you need to have multiple down conductors. It is not like the whole lightning, the entire lightning current is flowing through one down conductor, which is again danger, because if the whole lightning current is flowing through one down conductor, if you zoom this particular picture, the third line from top to bottom, also the horizontal line in the building is nothing but the These are nothing but you can, I'm just zooming the picture. These are the electrical, one is from top to bottom, the third is a conduit through which the electrical wire is running, and the horizontal one is also electrical wiring. In practical, what will happen is if there is a lightning strike in this building, the down conductor is carrying enormous amount of current, and the vertical pipe and the electrical installation, the vertical pipe which is going from top to bottom of the building, there are two down conductors and one electrical wiring. This electrical wire and the wiring and the connected equipment will disappear immediately. Disappear in the sense it is completely going to burn. It will create a burning of the rooftop solar PV system. Also, it is going to burn all the electrical items which is connected on the other side of this particular line. So basically, you have to have a lot of down conductors, number of down conductors, depending upon the size of the building, throughout the building. The idea is lightning current is separated to several paths or diverted through several paths. As a result, the amount of current flow through each of the down conductor is reduced to a low level, and its effects are thus reduced. So one down conductor like this particular installation is really dangerous. So even the standard says you can go you have to keep only 3 meters away from a down conductor. Please note that that is applicable to a building where a lightning protection as per 62305 is installed. Whereas in this particular building, lightning protection system as per a story is installed, not as per a standard, but as per a story is installed. One down conductor here, probably you should keep 10 meters away. As like the tree, the 10 meters, you must keep 10 meters away from this particular conductor, otherwise it is going to create a real hazard. Then the down conductors are connected to an earth electrode. As you can see here, there is a pipe or a plate or something like that, most probably a pipe. Each of the down conductor is connected to a rod, one down conductor connected to one rod. This is also an illogical, and this is also a non-standard installation. I would recommend children, please don't go near to this particular installation. You must keep at least 10 meters away from this particular place during a lightning strike. If you are going near to this installation during lightning strike, then you can be hit or hurt by lightning. So please keep at least 10 meters away from this particular installation. I also request the participants, please note that such dangerous installations shall not be done in a school. Small children are going to play sometime in this area, and no one can control children and tell them you have to be inside the building. This is the the boys' hostel in a school. Imagine during the afternoon, if on a Sunday no teachers are there, if children are playing nearby outside this area near to this down conductor, and there is a lightning, then they are in deep trouble. So such installations shall not be made. This is completely a violation of these standards. Not only the violation is not only on the down conductor and the earthing, the violation is also on the air termination system. One of our a volunteer from NFE, went to this particular school, and he had a talk with some of the villagers. And the villagers of the impression that this rod, where I'm moving the cursor, is going to protect not only the school building, but about 117 meters all around the school. So this rod is installed, and a story has been given to the villagers that you and the whole area is protected, which is also a non-standard installation or a non-standard theory. Once when we talk about non-standard theory, there are three types of non-standard lightning protection systems sold in the market. The first one is called as early streamer emission. It says one rod protect up to 100, or one rod catches lightning up to 100 meters, and this can protect a building up to 100 meters. So you protect yourself and all your neighbors by this particular rod. This is the claim which we say as non-standard. The second theory says the first theory is like an umbrella. The second theory is like an umbrella, but a reverse umbrella. So it is collecting all the lightning up to 100 meters. This is also a non-standard theory. And the third is called as lightning dissipating system. So this lightning dissipating system says once when a lightning reaches your building, after seeing this special rod, I will zoom it here. You see this picture. So the lightning is starting and there is a special rod, special installation at the roof of your building. After seeing this special rod, the lightning will go to your neighbor's building. So these three we call as a non-standard system. In this non-standard system, sometimes people are getting attracted towards the theory of early streamer emission device, which the manufacturers or the suppliers claim as advanced technology, modern technology, and sometimes simple technology, less maintenance. All the modern words are used: digital technology, IoT-based lightning protection, then probably artificial AI early streamer emission. All these attractive words are used: advanced, modern, then digital ESE, then IoT based ESE, and all these names are given. As a result of this name, as well as the marketing, the story which they explain, people are getting attracted towards this. So they say one rod protects 100 plus meters, and then there is a counter which you can count the number of strikes. So most of the time engineers are not attracted towards the first 3 points, but once when the manufacturer says this is as per the French code NFC 17102, then people are getting attracted. So the French code has accepted this particular claim, and they have made a standard with a picture. You can Google the standard NFC 17102. You can download the standard. Please download the standard, read the standard, and understand this particular picture. The French code says the NFC standard 17102, the lightning protection consists of serial numbers 1 to 18. It consists of one air terminal, which is nothing but the serial number 1 and ESE rod, then connection components, outdoor down conductors, several down conductors, and you see a lot of equipotential bonding and so on. So the French standard says this is how you should make a lightning protection system, and the Indian standard says this is how you should make a lightning protection system, but the serial number 1 is not required. The serial number 1 is about early streamer emission, whereas serial number 2 to 18 is the actual safety measures. The Indian standard says you don't need serial number 1, whereas the French standard says you need 1 to 18. Now, the fantastic part is the suppliers, when it comes to India, they don't talk about how to install and maintain it. They say one rod attracting 107 meters and it protects a large area, which is as per the French standard. This is a wrong idea. Even the French standard doesn't say that one rod attracting 107 meters and passing the current through one down conductor and one earth electrode. Even the French standard does not talk about it. Whereas the manufacturers, the suppliers in India always explain in this fashion: one rod, one down conductor, and one earth electrode, which is wrong as per the French code. So this picture you can find in the French code, which consists of a proper equipotential bonding. So, and several down conductors. Now, please note that lightning protection is not about a rod or conducting the current through one conductor and sending it to soil. We are talking about a very high current flow through a very small duration. The current is going to jump to all the nearby metallic objects. It is going to get coupled to the metallic installation. So we have to have a very good equipotential bonding as well. Once when it talks to this non-standard lightning protection called as early streamer emission sold in India, for example, solar PV installations, almost 99.9% of solar PV installations are made with early streamer emission device. I will show you how this becomes illegal in India in a later slide. So the theory of these protection, these manufacturers say, or they say, a normal rod is able to emit a streamer of, let us say, X distance. The early streamer emission device is faster, it is more capable, and it is able to emit a streamer of a higher distance. So based on this theory, which is never accepted anywhere in the world because the ESE vendors could not show it practically to anybody. Only in their closed laboratories they test and they claim these particular figures, but it is never, it is several occasions it is proven that or proved that the claims are totally wrong. So they say there is a delta t time advancement, then there is a complicated calculation, and based on the calculation they say, since my rod is faster, I can protect 108 meters or 102 meters. But when it comes to India, earlier days, there were some trainings going on. 2018, 2020, the video, probably the link I will post in the chat box. You can see the link. Earlier days, the claim was each of these ESE rod is protecting up to 2.4 kilometers. So 10 rods probably is going to protect the entire village or entire town. So such illogical and unrealistic claims were made in India for a long time. Now, what is written in the National Building Code of India? National Building Code of India is not a legal document. It is a voluntary recommendation. For example, the authority, those who are going to accept NEC, for example, the fire departments had accepted National Building Code as a legal document. So now any kind of ESE, CSE, and dissipation system, these three items shall not be used as per National Building Code. There was a court case, and finally the court told the National Building Code is only a recommendation. The authority, those who are implementing the act or the rule, must ensure whatever required. Now, if you look at the Electricity Act and the Central Electricity Authority, measures relating to supply, and you see the regulations, the National Electrical Safety Regulation 2010, Chapter 3 is talking about the general safety requirement. The regulation number 12, general safety requirement pertaining to construction, installation, protection, operation, and maintenance of electric supply lines and apparatus. The sub-regulation number 3 says the material and apparatus used shall conform to the relevant specification of the Bureau of Indian Standards or International Electrotechnical Commission, where such specifications have already been laid down. So the regulation is very clear. It says whatever the materials which you use in a building for making an electrical safe building, you must, all the devices must be as per the IS standards. And in the IS standard, especially the National Building Code, it is very clearly written that these non-standard devices shall not be used. So legally, using these non-standard devices there is no legal protection. It is actually illegal. Now this ESE rod, please note that, as I said, IEC 62305 or NFC, these are applicable for a properly constructed building or a structure. It is not applicable for an open area. Now, by taking this theory from the manufacturer, from the suppliers, it is applied all over India, and thousands of such ESE rods are installed across India. In the farmland, you can see in the picture, there is an ESE rod which is installed in an open area in a metal pipe, and they say it protects sometime 2.4 kilometers. Some places they say earlier it was 2.4, then it is reduced to 1 square kilometer, and nowadays I think the claim is only about 100 or 110 meters. So all these claims are illogical. It is not going to work. So, and even if you read the NFC standard, the protected volume in this NFC standard, depending upon the level of protection, the rod, it is sometimes only 20 meters, 30 meters, even if you apply the formula. Anyway, those formulas are also not at all applicable, not explained or accepted in anywhere. If a tree grows above the height of this ESE rod, then the claims are totally wrong because the lightning will go to the tree. Imagine there is in 2020, you put this kind of a rod, which is probably 50, 75,000 or even a lakh of rupees. And after 1 year, a nearby tree is taller than this particular rod, then the claim itself is wrong as per the standard. However, the claim in the standard itself is wrong. That is the point. When it comes to the education of lightning protection in India, you can find a lot of funny, non-scientific claims in with respect to lightning. It was claimed that there are different lightning strikes like hill lightning, jungle lightning, river-based lightning, coastal lightning, urban and semi-urban lightning. These are different. There are different types of lightning. This is what is claimed by the experts in India. This is absolutely wrong. And some places they educate that it has got low frequency sound, 1 to 30 megahertz sound, which we normally listen. This is nobody knows what is this 30 megahertz. We read in school that engineers know that the sound frequency is quite lesser than 30 megahertz. Then there are the I'm talking about the wrong training. Please note that this is the slide is explaining wrong methods, not the correct methods, wrong methods. So people are also educated as there are vertical strike and lateral strike. In farmland, people are affected due to lateral strike. Please note that it is due to step potential, not lateral strike. There was a propaganda during 2016, 2017. The propaganda was you plant tall trees all around the building or plant tall trees as a result of the tree. Lightning is dissipated by the tall tree. And one funny moment is, I think in 2018, the Bangladesh government started a project to plant palm trees to protect people. After 3-4 years, they realized that the palm trees are taking more time to grow. So they abandoned the project. The minister, one of the minister has made a press statement and it is provided in our blog. The minister says, since the trees are taking so much time, the idea of protecting people by planting tall trees is not working out well. So we are abandoning the project. But that project itself is a big dangerous idea, planting tall trees and protecting from lightning. Then we were also taught that if you in your building, if you have a compound wall, then lightning is completely protected. You know, within the lightning will not jump out of the compound wall. People think that, or the Indian scientists think that lightning is like a thief. He will not jump out of the compound wall and don't go out. So all such unscientific and wrong and dangerous methods are being propagated or educated in the schools and colleges and communities around India, especially in northern part and the eastern part of India. Please don't believe all such things. It is also educated, a wrong education saying that lightning conductor, it will conduct a negative lightning strike, and there is lightning arrestor, which will protect a large area, and this lightning arrestor positive lightning strike is dissipated, lightning negative strike is attracted, and all these non-standard things are being educated, and the non-standard education also try to claim that these lightning arresters, which you are seeing, the ESE rod is installed in Parliament of India, Qutub Minar of India. So this is a sign of acceptance of this technology in such large buildings. Please note that lightning is not a daily phenomena. If lightning is not going to hit Parliament of India for next 20 years, yes, it won't hit. That's it. So it doesn't mean that this ESE rod is protecting the Parliament of India for next 20 years. So also the manufacturers were claiming that in one of these Indian scientists worked in Switzerland, and he used the cow dung for attracting or sending the lightning current to Earth. So really, the situation is really pathetic. It is not good to follow such non-scientific methods. You please download or get the Indian standard, read the Indian standard properly. The standards are made, these standards are used globally. Lightning is same all over the world. Probably only the amount of current is lesser, or here and there it may be different, but that is with respect to standard. It is immaterial because all the side effect or effect, direct or indirect effect of lightning is already included in the standard. So you can blindly follow the standard. These are made after research by hundreds and thousands of universities and experts around the globe. It is not like somebody sitting in India making a standard and asking all the people to follow. So also this is a wrong training. I have put special training, not special training. This is a wrong training. They say lightning arresters and devices which arrest lightning before it is formed, and hence there is no sound and lightning. This was one of the claim. I don't know what kind of lightning arrestor it is. They say the after installing the special device there is no sound and light, so no lightning. So there are cities and towns and places which is completely protected. The Babadam and some these places, airports are safe grid. That means the entire area is protected. So if a lightning protection an expert listen to the trainings which is happening in India, then only you will realize the dangers behind it. One of the dangerous method which is explained during this training is using a cycle tire on a wooden pole, fitted on a wooden pole, and claiming that this will protect the for example this school building. Also it protects it is claimed that it protect these people, those who are behind. But please note that this is impossible. You must be at least 10 meters away from this particular cycle rim. If you are 10 meters away from the cycle rim, then the even if there is a lightning strike on the cycle rim, step potential effect will be almost 10 meters. So people, those who are thinking that this is making people safe, and if you go behind or below this particular cycle tire, people will be hurt due to step potential, due to touch potential. 3 meters is the distance. Even if you have a good installation, you have to be 3 meters away from the installation. That is what is explained in the standard. If it is a unsafe device or a tree, you must be 10 meters away. So look, non-standard and unheard systems are used in order to protect people in India. Bicycle tire and cycle rim. The funny part is during 2018, it was only claimed as a bicycle tire. But once when we published an article and told them that there should be a down conductor, then the claim is changed as, okay, now the cycle tire is connected to the earth electrode through an 8 millimeter wire. But please note that it won't work. In the sense, first is, imagine, even if the lightning is hitting this cycle tire, lightning current, once when it flows, it produces enormous amount of mechanical force. Even if you have an 8 mm down conductor hanging from the cycle tire, this wire will disappear and it creates a flashover all around the area. You cannot do like this. What about the touch potentials? What about step potentials? So this is in fact highly dangerous. And it was claimed that tens of thousands of these non-standard things are installed to protect school children, to protect hospitals, and so on. Recently, we saw another method which is claimed to be an alternate, and as per IS/IEC 62305. The claim is as per IS/IEC 62305, which is also not correct. This is, you see a metal pole instead of a cycle tire and a wooden pole. There is a metal pipe, 13 meters long metal pipe, and connected to two earth electrodes, as you can see here. And the claim is it protects a 45 degrees shadow area. But please understand that the standard recommends you have, if you are earthing, if you are in a poor installation, you have to be 10 meters away from the conductor. So if you are moving 10 meters away, if you go to the corner and if you make a 45-degree angle, a person who is standing at the last 1.5 meter is not protected because lightning may be hitting his head. You are exposed. So if you make this kind of an installation, actually you get, this is the entire area, let us say 45 degree, which is claimed to be protected area. So 10 meters, the red dot is the metal pipe. 10 meters from the metal pipe is unprotected. You will have touch and step potentials. At the finally, the area which you are going to get in order to protect people is the green circle. If you are going to the red area, that means closer to the pipe, you will get hurt due to touch and step potentials. The orange area, you may be exposed because you are taller than the protection angle. You may be getting hurt. So the green area is the only protected place, and you cannot really make a boundary like this green area and tell people that during lightning, all of you go march to this green area and stand in this particular area in order to protect. This is impossible. So basically, this idea of making a metal pipe and connecting it to two earth electrode and claiming that this is as per the Indian standard is wrong. Indian standard don't talk in this fashion. Even if we think that there is a very good earth electrode and the distance from the pipe is not like 10 meters, let us say 1 to 3 meters, even then the actual place where you are getting is quite less. It is not like the entire 45-degree shadow area is protected. So please understand such dangers and educate the people properly so that they are not fooled because of this foolish education happening in India. Similarly, it was claimed that the cyclone shelters, hundreds of cyclone shelters across India are protected with lightning protection. So you can find this report in one of our blog. This is how the cyclone shelter looks like, and there is an entirely isolated lightning protection, which is practically required for an explosive area, like an oil tank. So a lightning protection, which has to be implemented for an explosive area, is being installed in this building, which is a cyclone shelter come go down. And after 2 years, you can see that this whole thing is totally damaged. And this project, for example, protecting this building, it is worth probably the lightning protection alone is worth probably 40, 50 lakh rupees because these are special wires, high voltage insulated conductors. And these conductors has to be fixed to the wall of the building at every half meter, whereas the wires are completely hanging. If the lightning is hitting due to mechanical forces, all these installation will be thrown away. It is not going to exist. Now, protecting people inside this shelter. This shelter is an RCC building. It's a properly constructed RCC building. You don't need to have lightning protection for this building to protect people. If you wanted to protect the structure, you need to have a lightning protection system. If you wanted to protect people, simply ask the people to go inside the building, let them sit inside the building, don't go near to windows, and don't touch electrical items. That is the safest way. So people inside the shelter, if they are away from the windows and doors, and if they are away from the electrical installation, then they are safe. You don't need this lightning protection system for this cyclone shelter. Whereas tens of crores of rupees has been our money, the tax money has been wasted for such installations, claiming that these are high technology protection system. So people inside RCC are protected. It was also claimed that lightning protection, people, the risk assessment and risk management. There is a claim going on in the media which says that risk assessment as per the Indian standard is wrong, because sometimes the people, those who are talking, they don't understand what is the difference between risk assessment and risk management. What is explained in the standard is risk assessment of a building, not an open area. It is not applicable for open area. It is not applicable for a traveling vehicle, a vehicle which is moving. It is applicable for a fixed structure. Now, for that, how to make a risk assessment? Risk assessment is nothing but finally you sometime require finally there are three questions: LPS, lightning protection system, whether you need or not. So risk assessment is to find out whether your building require lightning protection or not. Risk assessment is, for example, in the previous slide, you have seen the cyclone shelter. If you make a risk assessment, probably this building, that particular cyclone shelter, doesn't need any lightning protection because the building is already protected by the steel structure. Now, if you require lightning protection is divided into 4 levels: LPL 1, 2, 3, 4. The whole story of risk assessment by the way of calculation by the number of thunderstorm days, size of building, type of service, number of people, criticality in case of failure. And finally, on one side, we are finding out how much how much money or how much economics is involved in case of a lightning strike and its related failure. On the other side, how much money you are going to spend to protect a building. And at the middle, you have the tolerable risk. The idea is 1 out of 10 to the power 5, that means about 1 lakh strike must be protected for human. Say, for example, out of 1 lakh lightning strike, only 1 lightning strike shall be harmful to a person. Similarly, for electronics, 10 to the power of 3, that means out of 1,000 strikes, 1 lightning strike can be harmful to electronics. So these are the tolerable risks. Always the risk assessment is to ensure that the building, the tolerable risk, the whatever we are, by installing lightning protection, the tolerable risk is reduced to less than this particular level. The risk is reduced to less than tolerable limit. So people should understand that the standard is not talking about risk management. Risk management and risk assessment is two different subjects. What is written in the standard is risk assessment. It is through calculations, just find out whether your building need a protection or not. It is not applicable for open areas. It is not applicable for non-standard constructions. If you wanted to protect people outside the building, the only way, the best way is to put a metallic container and people probably inside the metallic container, but it is not practical. It is and very expensive. One of the method which can be thought of is, instead of a metallic container, you can make a metal shed with metal supports, and this red color is nothing but several ring conductors outside the building, inside the building, in order to make a proper earth potential uniform. So this may be a solution. It is not scientifically, if required, through softwares we can analyze, we can simulate, and we can test whether this will work or not if there is a demand. But this can be a practical solution. A metal shed with metal supports, that means the roof is properly grounded. Then on the earth, all the metal poles are interconnected to a kind of a grid all around the area, inside and outside the building, so that potential equalization is also made. So if you wanted to protect thatched roof, then the only way is you have to make ring earthing. Also, please note that if you wanted to protect any place against step potential, the idea is to make a ring conductor all around the area, including the potential equalization, like extending the ring, which I have shown in one of the picture. Let me show that picture again. So even in a well-protected building, by extending the ring, you can make equipotentialization so that people outside the building are safe. A similar arrangement may be made to protect people outside this particular shelter. Schools, be very careful to protect people outside schools and hospitals. It is not the strike which is killing, it is the step and touch potential and flashovers. Equally, they are also equally dangerous. The area, preferably wherever people are standing, that area we are supposed to make additional ring conductors and make the area equipotential plane. And the equipotential plane must be connected to the air termination at several intervals depending upon the standard. For example, level 1 10 meters, level 4 20 meters. So, and you have to make a proper protection for these kind of buildings. It is not like place a wooden pole and a cycle tire and claiming that the whole area is protected or people are protected, which is really dangerous. You have to make a proper lightning protection system. Similarly, protecting the thatched roof. So the main subject is, it is not an earth electrode, but a ring conductor all around the building. So with this, I would like to stop the presentation. I hope the information which was given is useful. Now we are ready for the question answer.